Hey guys, welcome back. In this video, we're going to be talking about JavaScript data structures. Now, data structures are something that you're going to have to master regardless of what coding language that you learn. However, once you've mastered them, they can be applied to every coding language. So in this video, I've broken it down into the key concepts that I think you need to know in order to use them. If that sounds interesting to you, let's get started. Hello, and welcome back to another JavaScript video. I'm really excited to get started with this one today because these data structures are going to be great foundational knowledge regardless of what coding language you want to learn. Now, other languages might have their own version of these data structures, but if you're able to master these, then you'll be well on your way. Now, in the last video, we talked about the primitive data types, numbers, strings, and booleans, as well as other programming fundamentals such as if statements, loops, and functions. Now in this video, the 5 main data structures that I want to focus on are arrays, sets, maps, objects, and classes. Now the reason that I decided to make a separate video for these 5 data structures is because you first need to understand the primitive data types as well as the JavaScript programming fundamentals before you can start using these. Now the reason that there are different types of data structures is because each of them should be used in a different way. And in this video I want to talk to you guys about the appropriate ways that these data structures should be used. So let's start first with arrays. To initialize an array, use the let keyword and then name the variable whatever you'd like it to be. And then set that variable equal to opening and closing square brackets. This is how you initialize an array. Now you can think of an array as a list. And you can add things to the list by doing the variable name of the array dot push and then putting whatever value you want into the array. Now this value that you add can be any primitive data type as well as any of the more complex data structures that we're talking about in this video. If we want to see what's in our array, we can use our console.log function that we learned about in the last video. And if we open up our terminal, to open your terminal, you can either click Control tilde, or you can go to your toolbar up here to Terminal, and there should be an option to open a new terminal. Now, if we want to make sure that we're in the right directory, we can type in ls, and we should see our script.js file. If we want to run it, we just type node, a space, and then script.js, essentially the name of our file. And if you hit enter, then you'll see that it prints out the array. And inside of the array is the number 3. Now if we go ahead and add another value inside of this array, let's this time add the number 4, and we run our code again, then you'll see the array now has the values 3 and 4 in it. If we add another value inside of it, this time let's add a string. And we can see that the array is able to contain both numbers and strings. We could also add a boolean inside. So now that we have some data inside of the array, let's talk about how we can access it. In arrays, there is this concept of indexes. And indexes correspond to what position in the array your associated data is. So in this case, if we look at the bottom down here, you'll see that this 3 is in the first position, this 4 is in the second position, this string bang is in the third position, and this boolean true is in the 4th position of the array. So there is an inherent order to the array. If we want to access the very first item in the array, then we will simply put square brackets after the name of the variable and put the number 0. This 0 is the index of the very first value in our array. So if I run our code now, it's going to return 3. And the reason for that is because 3 is the first value in our array. Now, as you can imagine, if I want to return 4, we'll change the 0 to a 1, and it will return the second thing in the array. If we want to return true, which is the last thing in the array, we'll have to count 0, 1, 2, 3. And if we change this index to 3, then we should return the last thing in the array. Now, what happens if we change this index to 4 and we try to run our code? We get undefined. And the reason is because there is no value stored at the 4th index inside of our array. Now, something that might be a little bit confusing is even though this 3 is in the first position of the array, the index of it is 0. And even though this 4 is in the second position, the index of it is 1. So just know that the first index of the array starts at 0. Now something else that's useful is we can also remove values from the end of the array as well. So if we go ahead and change this console log to print out what the array is after we've added 4 values to it, we can use another function called pop, and pop will remove the last value from the array. So if we console log the array after we've popped the last value off of it, then we'll see the first time that we print, it has all 4 values. However, once we called the pop function and then printed our array again, the array now only has 3 values, and the value of true, which was the last value in the array, has been removed. And when you pop a value off of an array, you can actually assign it to a variable. So if we instead used let value equal myFirstArray.pop, then we could also console.log value, and it will print that out as well. Arrays also have an attribute called length. So if you want to find out how many items are in an array, you can simply use the name of the array variable .length. And just for comparison, let's compare it to the length after we pop the value off of it. And if we run this, we'll see that for the first console log, it prints out the value of 4, because there are 4 values inside the array. The second time, after we've removed a value, it prints out 3, because there are only 3 values inside the array. Now, if you remember last time, we talked about for loops, and the great thing about for loops is that you could get it to repeat the same code multiple times, but only if you knew how many times you wanted that code to repeat. We can use this length attribute off of the arrays to dictate how many times we want the for loop to run. So for example, if I wanted to print out every value inside of this array, I could use the normal for loop syntax, for let I equal 0, I is less than myFirstArray.length, I++. So if I comment out these 2 lines, then you see myFirstArray.length should be 4, because I have 4 items inside of the array. And for each iteration of the for loop, the value of I keeps changing. I starts out at 0, and because we say that we want the array to run until I is no longer less than the length of the array, then we essentially tell this for loop to run 4 times. Because once I is equal to 4, it will break out of this for loop. The great thing about this is now if we want to access each of the values inside the array, we can console.log, and inside of here we'll put myFirstArray, we'll use the square brackets, and place an index on the inside. And this time we'll just put the value of I. I'll go ahead and also print out the value of I before we print out the value inside the array. So if we go ahead and run this code, we'll see that when I is 0, the value is 3. That's because 3 is the first value in the array. The second time, I has now been changed to the value of 1, which means that the value that gets returned is the second value in the array, which in this case is 4, and so on until we've reached the end of the array, at which point I is 4 and array.length is also 4. Because 4 is no longer less than 4, we break out of the for loop. And we don't have to return any undefined values, just like when we used an index that didn't exist in the array in the previous example. Now there's actually another type of for loop that you can use specifically for arrays. If we simply just wanted to print out the values and did not care about what indexes they were, then we could use something called a for of loop. Now in a for of loop, you start with the keyword for, and then inside of here, you define a new variable. You can name it whatever you want. We'll just name it value for now. And use the keyword of, and then you just type in the name of your array. And then inside the squiggly brackets, you can write the code that you want to repeat for each value inside of the array. So if we console.log value inside of here, and we run our code, we'll see that we print out each of the values inside of the array. For each iteration of the for loop, the value of this variable value changes to be each of the values that's inside of my first array. The next data structure that I want to talk to you guys about is called a set. Let's create our first set. First, we have to make a new variable, and we'll set it equal to the constructor function set. We'll talk a little bit more about this syntax later, but just know that this is how you create a new set in JavaScript. Now underneath here, just like the push function that we used for arrays, sets have a function called add. So if we take our variable myFirstSet and you do dot add, and inside of here you add a value, and we console.log myFirstSet, then we'll see that the value that the terminal prints out is a set, and inside of the set we have the value of 3. Now let's add a couple more things inside of our set. We'll add the value 4, we'll also add the string bang, and we will also add a boolean. So just like with the array, you see that the set can also contain all 3 of the primitive data types. And sets can also contain the more complex JavaScript data structures that we're talking about in this video as well. The interesting thing about sets is that they cannot contain duplicate values. So if I go ahead and try to add the value 3 again, and we run our code, then we'll see that the set has remained the same despite having added 3 twice. But if we go back to our array code up here, and instead let's try to add the value 3 again. If we push the value of 3 twice to myFirstArray, and we print out myFirstArray, you'll see that the 3 is added twice. However, down here, when we added 3 to the set, 3 was only added once. This is a very powerful tool if you're trying to find unique values. Now, just like with arrays, sets also have an attribute to determine how large they are. So in this case, instead of using .length, sets have an attribute called .size. So if we run our code now, you'll see that it prints out 4. And the reason is because our set only has 4 values, 3, 4, the string bang, and the boolean true. Even though we added a 5th value here, because that value was a duplicate, it actually does not get added to the set again. Now, if you ever want to remove a value from a set, you can just use the function delete. And inside of here, let's say we want to remove the value of bang. If we run our code, you see that before the delete, the set contains all 4 values, 3, 4, the string bang, and the boolean true. But after the delete function is run, we console logged our set again, and this time we only have 3 values, and the value of bang has been removed. For sets, you can also use a for-of loop if you want to iterate through all of the different values in the set. Now, if we run our code again, we'll see that the for loop was able to iterate through all 4 values that are inside of our set. Now, maps are the next JavaScript data structure that I want to talk about, and they are similar to sets, but a little bit more powerful. So think of maps like a machine. You put something into the machine, and then the machine spits out a value that's directly related to the thing that you put into it. Now, the thing that you put into a map is called a key, and the thing that the map spits out is called a value. Essentially, a map allows you to connect a key to a value, so that whenever you pass a key into the map, an associating value gets spit out for it. Let's go through a quick example. So let's create our first map, and it's going to look similar to a set, except this time we're going to do the map constructor. Now, if we want to add values to a map, we need to provide 2 parameters, and we use a function called set. Now, the 2 parameters that you need to provide when you want to add to a map is the key and the value. So let's go ahead and let's add a key of the string red and the value of 1. If we console.log our map, then we see that our terminal prints out that myFirstMap is a map object, and inside of it, we have the key red that will return the value 1. We can add more values to the set. This time I'll make the key blue, and the value that returns 7. And inside of here, we see our map now has 2 key value mappings. Now, going back to the machine analogy that we talked about, we can retrieve the value of 1 if we pass in the key red, and we can retrieve the value 7 if we pass in the key blue. The way that you can get a value for a key from a map is if you do the function .get. And inside of the get function, you need to provide 1 parameter, and that is the key. So if we put in the key of blue, and we run our code, then we see our console log spits out the value 7. And that's because 7 is the value that's associated with the key of blue. If I change this console log to now use the key of red, then it spits out the value of 1. Something to note here is that inside a map, you are not able to have multiple of the same key. So just like how in a set all the values inside have to be unique, all of the keys inside a map also have to be unique. The reason for this is because if we wanted to change the value for a specific key, we would have to reference that same key. So if we went down here and reassigned the key of blue, and instead had it spit out the value of 12, and we run our code, we'll see that the first time that we print out our map, blue is assigned to the value of 7. But the second time that we print out our map, blue has now been reassigned so that that key is associated with the value of 12. And similarly to sets, you can use the attribute size to determine how many key value pairs there are in the mapping. So if we run this, we'll see that both times that we console log myFirstMap.size, the size of the map is 2. Let's go ahead and add another value. This time we'll do green, and this will return the value 24. And if we print now, then we'll see that the first time that we console log the size, it's size 2, and the second time, it's size 3. And just like in sets, if you want to remove a specific key value pair from a map, you can use the delete function. And inside of delete, you just have to specify the key for the key value pair that you want to remove from the map. So let's remove the key value pair associated with red. And after here, let's console.log our map. So the first time that we console.log the map, you can see that it has the key value pairs associated with red and blue. The second time that we print the map, we've now changed the value of blue, and we have also added a new key value pair associated with green. And then the last time that we print out the map, we've removed the key value pair associated with red. Now, if we want to loop through all the things inside of our map, we can also use a for/of loop, but this time we'll have to use a function called keys that is built off of maps. Now, it's important that when you call keys, you have opening and closing parentheses at the end, because that indicates that this is a function call. Now, if we console.log key inside of here, we see that it prints out the strings blue and green. And the reason for this is if we look at the map, our map only has 2 keys, blue and green. If we want to get the values associating with those keys, then we can simply call myFirstMap.get and then put the key inside of that function as the parameter. Now, if we go ahead and run this code again, then we'll see that through each iteration of the for loop, it prints out key blue, value 12, and then key green, value 24. Maps and sets also have another function associated with it to see if there is an associated key already inside the map. Now, the way that we can see that is by using a function called has. And inside of has, we provide the key. So in this case, let's use has on the key of green. If we save that and run our code at the bottom, we'll see our map gets printed out, but you'll see the boolean of true also gets printed out because this map does indeed include the key green. However, if I change this key now to red, and if you remember on line 63, we removed the key red, and we run our code again, we see in our terminal that it actually printed out the boolean false. And that's because the key red cannot be found inside of the map. Now, the has function also exists for sets. So if we go back up here and we use .has in our set, and we want to see if our set includes this string bang, and we run our code, then we'll see it returns true. However, if we try a different value inside of here, let's say the value 7, because the values that we add to the set are only 3, 4, bang, and true. Now, moving on to our fourth data structure, objects. Objects are actually very similar to maps in that they similarly have a key value relationship inside of them. So if we want to define an object, all we have to do is make a new variable, and we set it equal to opening and closing squiggly brackets. If we want to add values inside of our object, then we'll just do the name of the variable dot whatever we want the property to be, and set it equal to whatever value we want that to be. So if we console.log our new object and we run our code, then we'll see it prints out an object which has a property name, and the value for that property is the string bang. Now, just like in maps, properties have to be unique. And if we tried to reassign this property of name, then it would just overwrite it instead of creating a new one. So let's go ahead and add another property, and this time we'll do age. And if we run our code again, then we see that now this object has 2 properties, name and age, and they have their associating values. If you want to remove a property from an object, then you have to use the keyword delete. However, this time the keyword delete goes outside and is not a function, and then you do the name of the variable dot whatever property you want to remove. So if we console.log our object again after the delete, we'll see for the first print, we have both attributes name and age, but the second time age has been removed. Now, if you want to see if an object contains a specific property, you can use the in keyword inside of an if statement. So in this case, if we wanted to see if our object had the key of name, you could say if name in my first object. And here we'll console.log I have this. And if we run our code at the bottom, we'll see that because name does exist inside of my first object, we do print I have this. However, if we change this if statement, so now we're checking to see if my first object has age, and we run our code, then we'll see it does not print I have this. And the reason for that is because our object does not have that age property. If we wanted to print out the specific value for this object, then all we would have to do is the name of the variable dot the name of the property. And if we print down below, then we'll see that we print out the name of the object. If I change this to age, then now we print out the age of the object. If we try to do a property that doesn't exist, then we see we get the value of undefined. So the syntax for setting a property for an object is very similar to the syntax for getting that property for the object. But besides dot notation, there is also another way that we can get and set values in an object. And it's going to look very similar to what we did with arrays. If you remember with arrays, we would use the square bracket notation. So in this case, if we wanted to add the property of height to my first object, we could do square brackets, and inside of here, we would put a string that is the property that we want to add. So in this case, we'll set the property of height to 90, and down here we console.log my first object again, we'll see that our object also has a height property associated with it. And if we wanted to get that height property, we could also use the square bracket notation, similarly to how we used the indexing notation with arrays. So if we run our code again at the bottom, we'll see that we print out 90, because this is the way that we can access the height property inside of my first object as well. If we wanted to loop through all of the properties inside of an object, we could also use the in keyword. So instead of using a for of loop, this will be a for in loop. So for let property in my first object. And then we can console.log property. And if we run our code, then we'll see that we print out all the properties that are inside of this object. And if we want to get the values associated with those properties, then what we could do is we could do my first object, square brackets, and put property inside of those square brackets. And so I'm going to also add this console log here so that you can see which values are associated with which properties. So if we run our code now, we'll see that we print out the whole object, and then we loop through the object and print out first the property name and the value of the name property, then the property age and the value of the age property, and finally the property height and the value of the height property. Now objects lend themselves very well to our last JavaScript data structure. Now the class JavaScript data structure becomes very important when you're doing object-oriented programming. Essentially think of classes as predefined definitions of objects. For example, if we had a class person, that person would probably have a name and an age. And every time that we have a class person, we would want to make sure that they have a name and an age. With objects, the properties and values are pretty freeform. You can freely add and remove them as you please. But with classes, we predefine the properties that we want for the object, and those have to stay. So the way that we define a class is using the class keyword, and then you can name the class whatever you want. In this case, we'll use the example of person. And then if you set squiggly brackets inside of here, we'll use another keyword called constructor. And constructor is a function for classes that essentially defines the properties that we want for those classes. So like in the example that I gave you, a person, we'd probably want them to have a name and an age. Now inside of here, to make sure that a person object has a name and an age, you will use this dot name equals name, and this dot age equals age. The keyword this is used to refer to a specific instance of person. So you can think of one of these class definitions as like a stamp. You first decide what you want the stamp to have, and then you can go ahead and stamp as many pieces of paper as you want. And every time you stamp a piece of paper, it will have the same thing. Now each imprint on each piece of paper is now an instance of the stamp. So in this case, if we wanted to create an instance of a person, we would go ahead and create a new variable, and we would use the keyword new, and then the constructor person. And if you look at this syntax and you look at what we were doing up above, you'll see that map does the same thing, and so does set. So set and map are essentially classes that were already built inside of JavaScript. This is how we define a class of our own. Now this is not it, because this constructor requires that we provide these two parameters as well. So inside of the parentheses after person, we have to give it a name, and we also have to give it an age. So now if we go ahead and console log my first person, we'll see that the terminal prints out that this is a person object, and that it is essentially an object that has attributes name and age. And if we wanted to do this again, we could create another person. And to use the stamp analogy, we could use this same syntax again. We'll call this my second person, and instead change the name and age, and we'll console.log my second person. And if we run our code again, we'll see that the first time it prints out the person Beng, and the second time it prints out the person John. Just like with objects, if we want to access a specific property for our person instances, we can use dot notation. So if we take my first person and we do dot name, then this should print out Beng. Whereas we'll take my second person and print out age. Because these are both valid properties that we've defined up here in the constructor, we should be able to get those values if we run our code. And indeed we do. The way that these properties get assigned is because of how we define this constructor function. This refers to the specific instance of person, which in this case is going to be my first person, the very first time that we create a new person. And we're assigning the name attribute to the name parameter that we've passed into the constructor function. Likewise, this is the specific instance of person, but we're going to access the age property, and we're going to assign it to the value of this age parameter that we pass into the constructor. So in this case, when we create a new person, the name parameter is Beng, and the age parameter is 25. And we are assigning Beng, which is the name parameter, to this .name, the name property for this person instance. And 25, which is the age parameter, is being assigned to the property of age for this person instance. So in the last video, we also talked about functions, and how functions are great because if we want to reuse code in multiple places, we won't have to duplicate it. We can just instead make a new function call. Classes can also have functions baked into them. But when a function is inside of a class, it's actually called a method. In order to define a method inside of a class, you simply come up with the name of the method, give it two parentheses, and then squiggly brackets. So no need for the function keyword. And in this case, let's just have this function console.log hi. Now all of our person instances that we created will have access to this method. And if we wanted to access this method, all we would have to do is we would have to do the name of the person instance variable dot say hello. And make sure that you also have the opening and closing parentheses. Without the parentheses, it's just a reference to the function. With the parentheses, we are now calling the function. And if we run our code, then we'll see that person2 has said hello. Now methods can also take in parameters. So let's say that we wanted to define another function, and we'll call it say hello to someone. And this time we pass in a parameter. And this parameter can be another person. And this time, instead of just console.logging hi, we want to console.log hello, but also append the person's name. So in this case, we want to use the person parameter that we're passing into our method, and we can do .name. So now down here, if we want to have person2 say hello to person1, what we need to do is we need to change this so the function call is say hello to someone, and say hello to someone needs to take in a parameter, and that parameter will be my first person. So if we go ahead and save this and run our code at the bottom, we'll see that the first method call, say hello, only prints out hi, but the second method call allows you to say hi to whoever you passed in as the parameter. Now this requires that the person that you pass in also has a name property associated with them. Let's say we write another method, and in this case we're going to call it introduce. Now for introduce, all we want the person to do is introduce themselves. So in this case, we could say my name is, and then we can append this dot name. Now again, this is a keyword that refers to the specific instance that is calling this method, right? So if we wanted to do my first person dot introduce, then it should say, hi, my name is Beng. However, if we called my second person dot introduce, in this case, it should say my name is John. And the name that gets filled into this print statement is all based on the person that called the introduce function. In this first line, on line 124, we had my first person, which is Beng, introduce themselves. So in this instance, this refers to the instance of Beng, and that's how it gets the name Beng. However, on line 125, my second person is the one that is calling introduce. So this is the person instance John, and the name attribute for the person instance of John is John. And that's why it says my name is John. So hopefully now you have a better understanding of all the different JavaScript data structures and the best ways to use them. These concepts apply to JavaScript, but are also extremely useful to understand if you're trying to learn any other coding language. Classes are essential if you're trying to do object-oriented programming. Now in the next video, we'll talk about algorithms that use these data structures to utilize them in the best way possible. I hope this video helped you out, and I'll see you in the next one.